Hello everyone and welcome to the Applied Small Models AI Lab. Today I want to show you a project that I have been working on. It is a context-aware model router for Claude Code. Normally, when you use a Claude Code, you pick one model at the start of your sessions, either it could be Opus, Sonnet, or Haiku, and from that point on, everything goes through that model, whether the task is really simple or really complex. So I want to see if we could make that decisions automatic. So I built a context-aware model router using vLLM semantic routers that sits inside the flow. Instead of hard-coding one models, each request is analyzed and routed to the model that best fits the complexity of the task. So let me show you how you could do that. Here it is, you have the model here, you have a Claude Code here, and you have another terminal which shows the routing behavior. So you can see here /model, and as you can see here, you have Opus, Sonnet, Sonnet 5, Haiku, and Auto. Auto is the point that we have integrate vLLM semantic router to automatically route your request based on the complexity. So let's pick that model. As a first comment, what we do here is that write a Python script that prints hello world, and save it in hello world.py. So we have asked these simple questions, and as you can see, the model has been routed toward a Qwen model, which is our small model hosted locally, and it just creates that script, and now it asks, do you want me to create a hello world.py? And then I would give authorization, and you can see here, again, it used this small model to create that script. So it says that it's done, I've created Python script, hello, I didn't write it in a proper way, hello world.py. All right, so now I ask what hello world.py is doing in one sentence. And again, you can see that it computes a kind of margins and thresholds, and it compared with the threshold that I already provided the explanation in my blog. And you can see also explanation in the code repository, and it just pick, given the complexity of a task that we have provided, one small models to be able to conduct the task. So, and now I ask more complex tasks. We say that well design and implement a thread safe LRU gadget with O1 get put then write concurrent stress test with. Now let's see. Oh, I need to stop this because I don't want to burn a token for that. So as you can see here, once we're writing such a comment, given the complexity of the task that we have here, it just routed automatically to Claude Opus. So as you can see, we are not bound on a model that we need to pick it upfront as a traditional approach. Now we are effectively, given the prompt that we are creating here, and given the question that we are asking, and given the complexity of tasks that we have, is routed dynamically toward desired models. The whole project is open source, and I have also written a detailed technical blog post explaining the routing logic and the architecture that we are using here. So you're more than welcome to to use that code and play around with that. The main idea is quite simple here. Instead of using the most powerful model and adhere on a static approach that we have, we often also choose the most expensive models. For every request that we have, we can now dynamically select the right model using routing. Such that the simple request, as you can see here, it moved to the smaller and faster model, and more complex coding task, it goes through the API to more complex task here. That's I strongly believe that provide us with a balance of three things here. We have like a performance, response time, and also the cost, and fitting onto the purpose. We do not really need run a monster truck for every single task that we have to solve, obviously. So what I'm going to do next is that I'll include the GitHub repository and the full blog post in the descriptions. So please have a look on that, try it with yourself on your workflow, and let me know what you think about that. Thank you very much for watching this video, and I'll see you in the next episode.